An industrial oven used to cure sand cores for factory manufacturing engine blocks for small cars is able to maintain fairly constant temperatures. The temperature range of the oven follows a normal distribution with a mean of 450 degrees Fahrenheit and a standard deviation of 25 degrees Fahrenheit. Leslie Larson, president of the factory, concerned about the large number of defective cores that have been produced in the past several months. If the oven gets hotter than 475 degrees Fahrenheit, the core is defective. What is the probability that the oven will cause a core to be defective? So the first thing we need to do is, on our chart, determine what part of this curve we're interested in. So I have the standard curve here, which is, I'm sorry, very poorly drawn. But if this is the mean right here, the mean is 400, excuse my drawing. The mean is 450. The value that we're interested in is 475, so that would be somewhere over here. Since it is greater than the mean. So this is the mean, and this is x. And it's telling us that we're interested in the probability of greater than 475. So we're interested in this part of the curve. We're going to plug our numbers into the formula. Remember, the formula is z equals x, that's an x, minus the mean divided by our standard deviation. So we have 475 minus 450 divided by 25, and the answer to this is 1.0. Now we have our z-score. We need to figure out the probability associated with a z-score of 1.0. We're going to go to our table, which I've already pulled up here, and we look for a z-score associated with or probability associated with a z-score of 1.0. So I come down here, 1.0, come across, and our probability is 0.84134. Our problem now is that this number here represents our x, and then this part down here. And we're interested in this part. So what I have to do in order to figure out what this area is, I take 1 minus 0.84 134 and the answer to that is 0.15 8 So the probability that the oven will cause the core to be defective is 0.1587.